Hi everybody, this is section 3.5 on parallel and perpendicular lines from our Hawks Learning College Algebra textbook for Math 101. And just as a reminder, parallel lines are two lines that never meet. They're in the same plane, but they never meet. So parallel lines would look something like this. And then perpendicular lines always meet to form right angles. So again, my drawing is not perfect, but kind of think like a plus sign. That's what they would look like. For the coordinate plane, they will look like the x and the y axis because that's what it is. So perpendicular lines meet to form right angles, and parallel lines never meet or intersect, but they're always in the same plane.
So parallel lines, the slope of parallel lines. If you look at two parallel lines, what's different? And if I were to draw in like an x and y axis. So here's our coordinate plane. We have two parallel lines on that coordinate plane. The slope of the two lines are always going to be the same. They just have different y-intercepts. So if you have parallel lines, the slopes are always the same. You just have different y-intercepts. So what we're going to do is we're going to find the equation in slope-intercept form for the line which is parallel to line 3x plus 5y equals 23, and it passes through the point -2, 1. So the first thing we need to do is our line is parallel to this line right here. Well, what we need from that line is, because parallel lines have the same slope, we need to find the slope of that line. So what we need to do is we need to take this equation, my 3x plus 5y equals 23. We're going to solve it for y, so we know what the slope of the line is. So I'm going to subtract 3x from both sides, and that gives me 5y is equal to -3x plus 23. I'm going to divide everything by 5, and that means that y equals -3/5 x plus 23 over 5. Now, all we need from this equation here is we need the slope. Our line is parallel to it, but remember, parallel lines have the same slope, different y-intercepts. So our y-intercept is not 23 over 5. Now, what we are going to do is we have the slope, and we have the point -2, 1. So we're going to use our point slope formula, y minus y1 equals m times x minus x1. And we are going to plug in the information that we know. So we know that our y value is 1. So it's going to be y minus 1 is equal to our slope is -3/5 times x minus a -2. So remember that becomes plus a positive there. All right, now we are going to simplify. So we're going to have y minus 1 equals, I'm going to distribute. So it's going to be -3/5 x, and then 2 over 1 times -3/5 will give me -6/5. And then what I have to do is to make it into slope-intercept form, I'm going to add 1 to both sides. Now remember, if I have -6/5 and I'm adding 1, we don't want to keep it in whole number form. We are going to put it into fraction form. So I'm going to turn this 1 into 5 over 5, and that will leave me with y equals -3/5 x minus 1/5, because -6 plus 5 equals -1/5. So this is the equation of my line, or our second line, not my line, but the line that is parallel to 3x plus 5y equals 23. So again, parallel lines, they have the same slope. So if you notice, both equations have the same slope, but different y-intercepts. All right, so our next example, or example 2, we want to determine if the quadrilateral, which again, a quadrilateral is a four-sided figure, that has the vertices -4, 2, 1, 1, 2, 3, and -3, 4, is a parallelogram. Remember, a parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. So, a parallelogram, and again, this is my drawing, so it's not fabulous, but it's something that looks similar to this. Opposite sides are parallel. So they want us to determine if the quadrilateral is a parallelogram. They gave us 4 vertices, or the vertices on the 4 corners of our quadrilateral. So really what we need to do is first, I'm going to roughly sketch our quadrilateral just so we can kind of see it. All right, so we have -4, 2. So 1, 2, 3, 4, 1, 2. So right there. 1, 1 would be right there. 2, 1, 2, 3, right there. And then -3, 4, right there. All right, so here is our shape. I'll connect it. Again, fabulous drawing skills. All right, so we have our points. -4, 2, 1, 1, 2, 3, and -3, 4. So what we are going to do is we are going to calculate the slopes of our lines. And we need both opposite pairs are parallel. So I'm going to start off first. I'm going to calculate the slope of -3, 4 and -4, 2. Because that's going to give me the slope of this line right here. So that is, let's see here. We're going to do m is equal to 4 minus 2 over -3 minus -4. And that's going to give me a slope of 2 over plus a positive. So 2 over 1, or 2. All right, let's look at the other line that should be, if it's a parallelogram, parallel to that, which is right here. I'm going to calculate the slope of that line. So I'll do 3 minus 1 over 2 minus 1. So 3 minus 1 is 2. 2 minus 1 is 1. All right, so we got a slope of 2. So for those 2 lines, the black lines there, they are parallel, the slopes are the same. But a parallelogram, both pairs of opposite sides have to be parallel. So that means that I also have to find the slope between these 2 lines. So I'm going to start with the -3, 4 and the 2, 3. Let's find the slope between these 2 points right here. And let's see, I'll do 3 minus 4 over 2 minus -3. So that gives me -1 over 5, or -1/5. And then we'll calculate the slope between -4, 2 and 1, 1. So that's going to be 1 minus 2 over 1 minus a -4. So 1 minus 2 is -1. And then we do plus a positive, you get 1/5. So the red lines that I sketched on there are also, they have the same slope of -1/5. So yes, this quadrilateral is a parallelogram because both pairs of opposite sides are parallel. All right, now, even though it says slopes of parallel lines at the top, we are actually looking at slopes of perpendicular lines. So we are going to suppose that the slope of line 1 and the slope of line 2 represent the slopes of 2 lines, which are not, neither of which is vertical. These 2 lines are perpendicular. So 2 lines are perpendicular. Remember, perpendicular, they form right angles. Okay. So here's my 2 perpendicular lines. Remember, the symbol for perpendicular is the upside down T. If and only if their slopes are, and they have to be both, opposites and reciprocals. So let's say the slope of one of my lines is 3. If my lines are perpendicular, the perpendicular slope would be the opposite of 3, so negative 3, and the reciprocal of 3, so it would end up being negative 1/3. So again, slopes for perpendicular lines are opposites and reciprocals. You have to have both. Okay, so here, we're going to find the equation in standard form of the line that passes through the point negative 3, 13, and that is perpendicular to the line y equals negative 7. All right, so this one is a pretty interesting question. It's a little tough because they give us the equation of y equals negative 7. Now, question, what is the slope of a y equals line? Remember, it's a horizontal line, so our slope is 0. Well, if I'm trying to find the opposite and the reciprocal, the opposite of 0 is 0, and there is no reciprocal because you can't, if I make it 0 over 1, you can't have 0 on the bottom. So remember, the opposite, if you have a horizontal line, is, so here's our horizontal line, the opposite of perpendicular would be a vertical line. And for a vertical line, what's the equation of any vertical line? It's always going to be x equals, and the slope is always undefined. So here's my question. If our point is negative 3, 13, that our line goes through, and we know our equation is x equals, what is the equation of this line? All you need really is your x value. So it's going to be x equals negative 3 for that equation. That one is a tough one because they don't give you, you have to use a lot of prior knowledge and you have to like kind of fish out the information a little bit. All right, so the last thing we are going to do on this PowerPoint is prove that the two lines 3x minus 7y equals 12 and 14x plus 6y equals negative 5 are perpendicular to each other. So remember, if they're perpendicular, their slopes are opposites and reciprocals. So the first thing we need to do is find the slope of each line. Remember, if it's in standard form, you cannot find the slope of your line. You have to put it into slope-intercept form. So I'm going to take my 3x minus 7y equals 12, and I'm going to subtract 3x from both sides. So I'll get negative 7y equals negative 3x plus 12. Divide by negative 7. So now I have y is equal to two negatives, make that positive, so 3/7 x minus 12/7. Now again, I really only need my slope. Okay, I don't really care about the x or the y-intercept right now. All right, for our second one, it is 14x plus 6y is equal to negative 5. So I'll start off, I'll subtract 14x from both sides. And that's going to give me 6y is equal to negative 14x minus 5. Divide by 6. So y is equal to negative, and I'm going to simplify the 14 over 6, make it 7 over 3, x minus 5/6. So my slope here is negative 7/3. Remember, to be perpendicular, the slopes have to be opposites and reciprocals. I have one positive, one negative, so that's good. The reciprocal of 3/7 is 7/3. So because the slopes are opposite and reciprocals, they are perpendicular to each other.